features, 1, feature 2, feature 3, 4, and 5. And I'm going to use all these features to predict the salary, right? So whenever I pass all these features to my model for the training, so what my model try to do, it will try to understand the patterns, each and every pattern in these features, right? How F1, F2, F3, F4, and it will try to learn from each and every feature. It will try to learn from F1, F2, F3, F4, F5, and use all these data to predict the salary here, right? So while doing this, what happens, sometimes my feature 5 may not be important, right? But still my model will try to learn something from this feature, try to understand the pattern here. So it is trying to consider each and every feature in my data set to predict the salary, even though this feature is really related to salary or not, we don't know. Suppose say that age, I have an age, experience, office location, and technology, and here I have a male and a female. So does really gender matters for the salary? Of course not. If you have a talent, yes, you will get a salary. It doesn't matter you are a male or a female. But still my model is going to understand, okay, if it's a male, then my salary is something, and if it's a female, my salary is going to be something. It will try to differentiate there, just because I have a feature here, which is not at all important in this case. So in that case, if model is trying to learn each and every data in all the features and trying to predict a salary, it will work during a training phase. Right? This is what I'm trying to do. I'm passing all these features and a label. Then I'm basically trying to train my model. During a training phase, it may give me 95% confidence. Right? It may give me around 100% of accuracy, or maybe 90% of accuracy, or 85% of accuracy. But fine, I'm getting 85, 90, that's wonderful. But this type of a model is going to fail when I pass test data. It is simply because my data in the testing data set may not have the same kind of my data in the testing data set may not be available in the training data set. And if it is not available, what is going to happen? My model has not seen such data during a training phase, and it will think that, okay, this kind of a data I have not seen during a training phase, so it will start guessing randomly, right? So in that case, my accuracy during a training, in a testing phase, it may come down to maybe 70% or maybe 80% respectively here. And here, if I have a 90% during a training phase, it may give me 75%, and here it may give me 65%. If you see this drastic change in the accuracy of my model during a training phase and a testing phase, that type of a model I'm going to call it as a overfitted model. I want my model to be generalized model. When I say generalized model, my accuracy during a training phase and a testing phase close to each other. If I have a 95% here, during a testing time, it should be maybe 92%. I'm okay with that. Here maybe 95%. I'm okay with that. Here maybe 85%. I'm still okay. 5% okay, I can accept it. Here maybe 80 up to 80%, I can accept it. Right? So if there is a drastic change, 15%, 20%, accuracy change between a training and a testing phase, right? So that time I'm going to call my model as a overfitted model. It's simply because it is trying to learn from each and every feature, even the features are not correlated with the label, right? So how to avoid this overfitting? We have discussed in the other video using the regularization, right? So we can apply some kind of a penalty and we'll try to avoid this overfitting model. So you can go ahead and watch the regularization model and you'll be able to understand that. So fine, this is a basically overfitted model. Now, what is a underfitted model? Let's take a same example, F1, F2, F3, F4 and F5, right? And I need to predict a salary here. So now, okay, so if I pass all the features, you realize that if I pass all the features, there could be a basically overfitting problem, right? So what you do, back of your mind, you think that, okay, it could be it is going to be a overfitting. So what you think, like, okay, let me do one thing, I will pass only F1 and F2 features only to predict the salary. So you are trying to minimize your features as much as possible. Yes, we need to understand here that we have to use as much as possible minimum features. But at the same time, we need to understand that all those features are basically contributing to predict the salary, or are we simply eliminating some of the features who are still contributing to the salary, right? So those kind of analysis I need to do. But in this case, for underfitting, if I say underfitting, so it means that I am trying to keep very less features, in this case F1 and F2, to predict the salary, though F3 is also important and F4 is also important in order to predict the salary here. But you are not considering that. You are just considering F1 and F2 and you are asking the model to predict the salary. So in that case, what is going to happen? Your model will not perform well, right? It will start giving you only 50% of accuracy, maybe 60% of accuracy, maybe 40% of accuracy, because it doesn't have those features which could really add impact on a salary. So you are trying to be so you are trying to give as minimum as possible from your point of view, but you are ignoring some of the features like F1, F3 and F4 that they are also contributing to the salary, right? If you use very less feature to predict the salary, if you are using a less feature to build a model, so you may end up getting a less accuracy. So that time you are building a underfitting model. So how do I avoid that one? I need to do some kind of analysis whether feature 1 is related to a salary, how feature 1 is related to salary, how feature 2, how feature 3 and feature 4 and feature 5, are there any relationship with the salary or not? And you need to pick all those features which are related to salary. If nothing is related, if any of the features are not in relation with the salary, that time you can ignore that feature. In this case, we have taken a male and a female. So male and female doesn't matter. So in that case, you can eliminate this feature and you can consider all these features to avoid this underfitting problem, right? So yes, that's the concept about overfitting and underfitting. And thank you for watching this video. See you in the next video and keep learning. Thank you.